Hi, I'm Anjay Jota, and I'm a PM on the Azure Intelligence Solutions Group. And with me today is my colleague, Dave Armour. You want to introduce yourself?
Hi, I'm Dave Armour. I work with Anjay. I specialize in customers using our solutions in the manufacturing industry.
Right, and we're here today to talk to you about how we designed, researched, and built a solution that we think will help manufacturers get started very quickly and with no data science experience, modernizing their factory lines with AI at the edge. So on the agenda for today, we've got what is the intelligent edge and our products that make it up. The Azure Stack family are a family of products that are designed to bring intelligence and Azure services right to your data center or other location. Kind of the efforts we've done to make developing and creating content and programs for the Azure Stack family easier. Our ideas and customer conversations around how we came up with the manufacturing solution and how we designed it, our development and review process, and finally, we'll show you the product we came up with. So I guess first, what is the intelligent edge? So our CEO, Satya Nadella, has this idea that there's an intelligent cloud and an intelligent edge. The intelligent cloud is a hyperscale computer that is available to everyone and can act in any capacity. And the intelligent edge is devices up from microcontrollers up to servers that live outside of the Azure data centers and that provide lots of data that can be analyzed either right at the edge or streamed into Azure for further analysis and archival. So when you combine these two approaches of the intelligent cloud and the intelligent edge, you get what's called a hybrid cloud. And so a hybrid cloud is great for quite a few reasons. You get the ability to operate in areas with little or no connectivity. You can cache things and then submit them up to the cloud whenever you get internet connection back. You can maybe meet some regulatory requirements. Things like data has to stay within the boundaries of a certain country. Or even, I need to speed up things and I need low latency because I need results now. Maybe you're dealing with some very time-sensitive process and you don't want to worry about the bandwidth limitations to the cloud. It's also a great reason to use a hybrid approach. And most enterprises that we talk to don't ever totally use an enterprise cloud or an enterprise edge. They use a combination of both. Again, it's that hybrid approach or multi-cloud strategy that allows customers to have the flexibility of choice to meet their needs and allows Microsoft to provide an array of options that make our customers happy. So the Azure Hybrid family consists of three parts. There's the Azure Stack Integrated Systems and Azure Stack Edge, which make up devices that sit outside the customer data center and provide Azure APIs. There's Azure Arc, which is a way to manage artifacts in any data center on any device through Azure. And Azure IoT, which is about very small devices analyzing and provisioning thousands and hundreds of thousands of those devices, getting all that data, aggregating it, and making sense of it, and allowing it to accelerate your business. So when we think about this, let's talk about the Azure Intelligent Edge and Cloud Taxonomy, how Microsoft sees different segments of this continuum. So at the smallest level, there's the microcontroller, which is things like Azure Sphere with secure Linux OS that's hardened against attack. And the next level up is IoT devices and edge devices. These are devices that can aggregate data from multiple sensors or maybe add a little bit of logic of their own, or they need more power, like analyzing video at the edge. And further up from that are edge appliances, like Azure Stack Edge, which allows for purpose-built hardware-accelerated machine learning at the edge. And further up is Azure Stack Hub. Azure Stack Hub provides full Azure services at the edge, with a full portal, the full set of APIs that you come to expect from Azure. And of course, at the farthest end of the continuum is the hyperscale cloud, with regions that span the globe and can be scaled up at will. So the parts we're going to focus on today are the Azure Stack Edge and Azure Stack Hub. David, if you'd like to talk about the Azure Stack portfolio.
Sure. When we talk about Azure Stack Edge, we're really talking about a cloud-managed appliance. This is an appliance that you can put into a remote facility, and then you manage it from Azure. This allows you to provision resources like machine learning at your edge or IoT solutions at the edge. Again, you manage this from within Azure, and you reach into that device remotely. Another handy capability is devices that you can, as the network is free, stream up the data back to the cloud so you could do future analysis on it. Azure Stack HCI is a way for you to modernize your operations around your virtualization technologies that you're already familiar with. This is kind of an ideal solution in your branch office or for high performance workloads. Azure Stack Hub is a cloud native integrated system where you get an entire instance of the Azure cloud that you could put within your own facility. That autonomous cloud can be disconnected from the internet or connected to the internet. You have the choice for doing that. And it allows you to meet your data sovereignty and maybe your contractual responsibilities, as well as start to modernize using cloud native technologies within your corporate network.
Sounds great. So I think what we're going to go into today are, again, Azure Stack Edge and Azure Stack Hub. Let's take a little bit deeper dive into those products. So as David said, Azure Stack Hub provides an autonomous cloud on premises that's great for disconnected solutions, things that require regulatory approval or regulatory boundaries for your data, and application modernization to take legacy applications that exist in systems of record that are legacy and upgrade them to modern microservices-based or Kubernetes-based applications. So that's an extension of Azure, which means it has the same tools, the experiences, the deployments, the application patterns, operations, and automations. And we have a lot of Azure services available on premises. We also have a lot of them coming soon. David, if you'd like to talk about the services that are coming soon, since that's what you do every day.
Currently under development are IoT Hub and Event Hubs. Those are full resource providers that will allow you to do advanced messaging as well as IoT management and two-way communication between them. Kubernetes, based on our AKS service in Azure, allowing you to manage your container applications. SQL 2019 is also under development. We will be bringing high-scale, high-volume SQL capabilities in later this year, hopefully. As well as you can see blockchain, cognitive services, stream analytics, and API management.
Right. So as you can see, we're constantly bringing new services down from Azure to Azure Stack Hub. This is, again, like that consistency and innovation flow that we always promise, that we're working to take the things that we build for the hyperscale cloud and bring them down to the public, to the hybrid cloud and the private cloud. Azure Stack Hub is offered as a purpose-built integrated system, which means that the hardware, the architecture, and the system topology, as well as deployment services, are all provided by a single point of contact. You work with your hardware provider to order the system, and then it gets delivered, set up, and integrated to your network in a white glove experience. This also means that you have one area for support. If something breaks with the hardware or with the software, you still go to Microsoft, and we work with the hardware provider to make sure you get taken care of. This provides a seamless experience that allows you to work on what you care about, developing applications and growing your business.
Right, Anjay. A lot of those things, people used to do it all by themselves, and having automated processes for each of those really makes a big difference for adopting cloud technology inside your own facility.
Yeah, absolutely. Application modernization is a huge benefit of Azure Stack Hub. So then there's Azure Stack Edge. It's a purpose-built device. Our current model is a 1U server class device, and it provides hardware-accelerated machine learning. It has FPGAs on board that allow us to use specially built ML models and accelerate them way faster than they could ever run on a CPU. We also have a few new features coming out for Azure Stack Edge, which includes the ability to have GPU hardware on board based on NVIDIA's T4, which will allow us to further accelerate our machine learning inferencing capabilities. We have Edge Compute, which is the ability to run VMs, containers, and Kubernetes clusters on some Azure Stack Edge devices. And this is all managed and provisioned through Azure. So this means that you pay by the month for an Azure Stack Edge. You can literally go to the Azure portal, hit new, and one will show up at your doorstep. And you get it all you can eat for 1 month. So again, this is what's coming in the future. The ability to have hardware accelerated learning with NVIDIA T4 GPUs or Intel FPGAs. You can use Azure ML or your own system and tool chain to develop ML models. And you can train at the edge with a GPU-based device. We have Edge Compute with the ability to run Azure VMs and scale across and build a Kubernetes cluster. And of course, this is all managed from Azure, and with Azure Arc, you'll be able to manage these workloads as well from Azure and create policies. And there's a cloud storage gateway that, as David mentioned, you can take data, copy it from your network to the device, and when bandwidth is free or you get an internet connection back, or at a certain time of night or day, that data will be streamed to Azure for further archival and analysis, allowing you to take data out of your local location. Hardware accelerated machine learning on Azure Stack Edge allows us to get data locally where it's generated to get immediate results. These are things like, if I have a lot of video to analyze, I don't want to ship all that data over the internet and bring the results back. I can simply analyze the data, throw away anything that's useless, and then only send the relevant things to the cloud. That saves me money, it saves me time, it saves me bandwidth, and it saves me space. And you can take action on things that connect to local systems or are behind a firewall. So kind of the goals behind these solutions are that, and in our previous efforts, are that customers want design best practices. When we go and tell customers about Azure Stack Hub or Azure Stack Edge, they say, this is great, but how do I build something for it? What's Hello World? How does this integrate into my application? How can I connect this to my legacy database and run a function to analyze data? And partners, Microsoft products aren't complete without a powerful and robust ecosystem. And our partners want a way to build software and offerings for Azure Stack Hub and Azure Stack Edge and a way to monetize it and market it. And developers need guidance. Again, that hello world. And developers, always like to look for things like code. They like to look for artifacts, guidance, and tooling. So we surveyed a lot of developers a couple years ago. We came up with hybrid cloud patterns. And these are things like hybrid DevOps, allowing DevOps software to deploy to both Azure Stack Hub and Azure Stack Edge, so Azure Stack Edge and your local systems and Azure. Cross-cloud scaling, the ability to take an application that's under load and scale it to run a cloud boundary from Azure Stack Hub to Azure Stack. Cross-cloud scaling is the ability to take an application and run it across cloud boundaries, scaling from Azure Stack Hub to Azure Public. You have data sovereignty and gravity. How do I analyze data that's required to stay in a country's borders and then get anonymized insights to a fleet-level analysis worldwide? AI at the edge, which breaks down into several different concepts of how we train, run, and version models that run at the edge with local data. Geo-distributed applications. In scenarios where I can't access the global Azure instance, I can route users to a local instance on an Azure Stack Hub. And tiering data for analytics. Can I analyze data in successively smaller steps, starting where a large amount of data is generated, throwing away the useless data, and passing those signals up to the cloud or other data streams? As a result of this, we created some guidance and artifacts. We created solution architectures that explain these patterns, and we created some tutorials that show you how to deploy them, along with best practices. We then created one-click artifacts, which were downloadable sample code. They're on GitHub, and you can find a link at the bottom of the screen. They combine edge to cloud development. We have all kinds of one-click artifacts for these patterns. There's ways to build hybrid applications, like with using the patterns I just mentioned. There's DevOps guidance. There's ability to build highly available applications using highly available SQL and NoSQL databases. And the thing is, as time went on, our customers, they said, this is great. We have the ability to start building things. But a lot of our customers don't want to have to learn all this by themselves. They want to be able to say, I have some building blocks that I can take and build a better solution. And to be honest, with all the customer conversations we did, we weren't really finding new patterns. So we started looking for the next thing. There we got edge patterns and we turned them into edge solutions. Edge patterns are common threads that we hear from customers for architects and developers to lead design conversations and include best practices. Edge solutions are made up of multiple edge patterns and they're based on kernels from customer scenarios. Our solution goals are to enable solution makers to see the product in action and figure out if it meets their needs. Now, David, you actually came up with kind of the framework for this. You had this vision for the solution that you wanted to create for manufacturing. Can you tell us a little bit more about it?
Yeah, well, one of the things that we learned is manufacturers are very busy and they can't spend a month doing an evaluation. They have very little time. So we tried to focus on how can we show them how to use the technology and do that within a single workday. So that as they have time, they can do one of our solutions as an experiment. And at the end of the day, they can go to their manager and show them how this technology can make a difference in their facility.
Right. So it's all about enabling that low time to value. So that way, David's customers or manufacturers can see this is not some cloud platform I bought. It's a way for me to modernize my business, and they can see that in action with sample code that we can give them. This also helps our field out. They are always looking for ways to show the value of Azure Stack Hub and Edge to their customers. And of course, this enables us to help out our ISVs. They're able to take these solutions and customize them to bring them to production for their clients. And of course, if a customer is large enough and they have their own development staff, the code is available for all of these on GitHub, so they can take it, break it apart, tinker with it, and build something totally new that meets their needs. So our current solutions that are here today are retail and healthcare focused solutions. We've got the ability to detect out of stock items on store shelves using Azure Stack Edge and a machine learning model. Footfall data collection, which is data collection of things that happen inside stores, the ages of the people who walk in, the number of people who walk in, how happy or sad they might be, and where they go, and processing that in an anonymized manner. And of course, we have a big solution for personalized retail. How, while respecting privacy, we can provide recommendations that are tailored to your shopping preferences and needs. And our new vertical for this year is healthcare, where we brought the Fire Server, which is the fast healthcare interchange resource, which allows healthcare facilities to communicate back and forth using a common language. We brought Microsoft SaaS service as a standalone service to Azure Stack Hub and Azure Stack Edge, so they can run this server locally. And we're working to bring a medical imaging platform to Azure Stack Hub, which will allow facilities to train and derive data from images and scans located on the network's premises. Kroger actually helped us with our out-of-stock detection model, and Sunrise Technology, their technology division, uses Azure Stack Edge as a retail as a service platform, which uses live video analytics on Azure Stack Edge at certain stores and enables those personalized guiding experiences. So we've found these success with these other verticals, retail and healthcare, and then we pivoted to manufacturing. And David owns the manufacturing vertical on our team. And David, why did we want us to tackle manufacturing next? Why is this so important to our product?
Yeah, manufacturers have facilities all over the world. Many of those locations have really bad network connectivity. Also, their operations inside the plant really can't depend on an internet connection. So largely, they want to be able to operate autonomously, yet get the value that they find in the cloud. So what we did is we actually went out and talked to a number of our manufacturing customers to kind of understand what they'd like to do on the edge, what's important for them there. And one of the things that we heard over and over again is, they'd like to do things with video and analytics, but, sending up video streams to the cloud really doesn't make a lot of sense. So they'd really like to take advantage of our Azure Stack family of portfolio to try to build a solution where they can do analytics to do things, for example, quality control or part identification, all within the edge.
Right, so that makes a lot of sense. So based on David's customer research, we picked manufacturing as the next vertical to work on. Then we moved into the design phase. And so this is where David took the scenarios from customers, and maybe you can give us some of those I can statements that your customers wanted, and then we translated those into other requirements.
Yeah, one of the things that we heard loud and clear is people are curious in video analytics at the edge, but they really don't know how easy it is to get going on that. So one of the I can statements that we have is, I can set up a proof of concept in a single day. Another I can statement that we learned is, I can set up a prototype without requiring any experts like data scientists to complete the task. So these types of I can statements really gave us an insight into kind of the scope of what it is we needed to build.
Right. So those are the I can statements, which formed like the general scenarios that we wanted someone to be able to do. So let's actually talk about the personas. Like who in the factory would end up using these? Because you said that you didn't want a data scientist to have have to take on this project, but who would end up using this, and how do we design for that?
Yeah, the people who see the value of this are the people in the factory. And, if you're in a factory in some remote location, it's very unlikely that you're going to have a data scientist there that can work with you to kind of fine tune models and things like this. A lot of these folks don't even know a lot of the terminology that we use in machine learning. So we really zeroed in on the person who has a task to do in the factory related to producing high quality products.
Right. So yeah, that makes a lot of sense. We want to make it easy for someone to use. One of the ICANNs is get started within a day. And so we broke those down into what parts of that ICANN are reliant on the backend API, for example, things to handle models, things to handle images, a web service, and the UX. How do we make it easy for someone who's never done machine learning in their life to click 1, 2, 3 and see it in action? And then, with all that data from the ICANNs, the UX, the API, and the personas, we had to figure out where this thing will run. So, David, you mentioned the Azure Stack family, but we kind of made a choice about Hub versus Edge. How did we arrive at that choice?
Yeah, we kind of arrived at Edge because this is something that we want people to be able to do in a single day without a large investment, right? And with Azure Stack Edge, you can get the device. It's a monthly fee. You can have it shipped to your facility. We handle all of the shipping. It's first party. You just deal with Microsoft, you order it straight from the Azure portal, and it shows up. It's a really easy way for you to get started. What we believe, however, is after people see the value of this, they'll want to invest in it even more. And along that, they might want to start to do like model retraining, all autonomous within their facility. And that might lead to a larger device, such as you would get with an Azure Stack Hub.
Yeah, so that makes a lot of sense. So let me actually show you some of the ICANN statements that are actually straight from the document we handed off to the devs. So things like I can add a camera, use it to register a part, which means train a model that says I will look for this part, and then reliably detect that part in a video feed, at 15 frames per second with a current detection rate in the maximum of 2 parts. So that scenario, you see it has a target for success. It has some constraints, so we're not trying to boil the ocean, but it's also very specific, so the developers and the testers know exactly the targets they have to hit.
Right, and we got more specific on this by calling up customers and finding out exactly how they would measure us for a successful prototype.
Right, exactly. And sometimes things that customers give us are a little bit more fuzzy. For example, that second one, I can easily install the solution on an Azure Stack Edge device managed by Azure. Easily varies for a lot of people, but David, tell us the kind of experience that your customers are looking for.
Yeah, we're focused on people who don't have a lot of pre-training or previous knowledge. We're also trying to target people who are not experts in machine learning or even in an Azure Stack Edge device.
Right. So and so that's important, that it be easy to use, easy to set up, easy to manage. And go ahead, David.
Well, we'll also test this as we go through different iterations. We'll have people come in, or we'll ask them remotely to install and give us feedback on this, and we'll find out whether or not they thought it was easy or not.
Yeah, actually, the most important part of all this, we're talking about customer conversations, the backgrounds. The most important part is that we have a tight feedback loop with our customers and users. That way we can make sure we're always on the right track and we're not wasting resources.
That's right.
Yeah. And so like our third ICANN is I can view, it's actually a third piece of functionality. I can view a sample of images and then retrain the model, where David was mentioning autonomous retraining as an eventuality for this product or this sample.
That's right.
Yeah. So Azure Stack Edge exposes Azure IoT Edge as a surface for you to run modules on that device. It provides access to the hardware, such as the FPGA and the GPU, or the shares to access the internal flash storage. And it also provides some really cool manageability things. So from Azure and soon to be Azure Stack Hub, you can use the Azure Stack Edge resource provider to add shares, activate a device, manage it, and do all kinds of lifecycle operations. And then you can configure compute and add it to IoT Hub, again, on Azure and soon to be Azure Stack Hub, where you can take all those messages that are flying around in the IoT Edge space and send them up to the cloud, store them, and analyze them as a batch across a fleet of devices. And of course, make sure that device has a consistent deployment framework and is the same as the rest of your other devices. So a lot of what we deploy for intelligence at the edge relies on containerized versions of Azure services. So With things like Azure Cognitive Services, the Face APIs are available. Azure ML, we can deploy ML models as containers on Azure Stack Edge. David, you worked on the stream analytics and functions that your team did. How do those compare to the cloud-based ones?
Well, the cloud-based ones, you configure it all within Azure. With the containerized versions, you configure them in Azure and then push them out to the edge.
Yeah, so exactly. Like it's a lot about being able to package a workload that you have in the cloud and export it to run anywhere you'd like. And of course, SQL Database Edge and Event Grid are both coming to Azure Stack Edge as containers, or Azure Stack Hub as containers. Or you can use our APIs and write your own container that runs on a Linux platform. So let's talk about how the Azure IoT Edge lifecycle experience works. So you have some kind of data with a sensor or a database or something, and the data flows into an Azure Stack Edge, and that analysis flows up to Azure IoT Hub. But in order to set the containers and the modules on the device, we use Azure IoT Hub, which provides a really comprehensive experience for saying, this is the goal state for the device, and this is where I'd like it to reach. And IoT Edge keeps trying to achieve that goal states and keeps trying to achieve that goal state and reports back the number of devices it's configured, the failures, and the kind of failures, so it's easy to see manageability across an entire fleet of devices, like 1 per factory or 2 per factory, but you can manage them all from a central place. When we build solutions for Azure Stack Edge, we talk about using things like on-premises devices that flow into a hardware-accelerated compute platform that can also access on-premises systems of record. Then that data is combined, and the relevant signals, such as like maybe anomalies or failures per hour, or even images that are problematic, will get sent to Azure IoT, or Azure Stack Edge in the cloud, or Azure Storage, or Azure Stack Hub Storage and Azure Stack Hub IoT Hub. Wow, that's a mouthful. And then they can interact with Azure services there to provide even richer and more amalgamated offerings. So combining the IoT Edge deployment and that Azure Stack Edge solution deployment, here's our solution architecture. We've got a camera that exposes an RTSP feed, which then sends a raw image to an inference module. Right now, in the first state of the program, it does nothing. But eventually, we have a web service that exposes a UI. We snap some images, we drop it in there, and then those are sent to customvision.ai, where it's trained, and the model is then deployed to Azure Stack Edge. At that point, inferencing begins. And then you can see results come up on the screen, and then those results are also forwarded to IoT Hub for further archival and analysis. So now that we've kind of talked about the design and how we thought about building this product to meet the needs of the customers that you've identified, kind of talk to us about the review process that you want to maintain that feedback loop so we don't go barking up the wrong tree.
Well, first of all, it's really important for us to do incremental progress in small pieces so that we can check ourselves and make sure that we're on target. Every new capability or new feature that we add, we want to go back to customers, reconfirm, then move forward after that. So we expect more customer conversations, more learning as we go. The same is true with our design research. That's, again, a very iterative thing we want to do after every sprint. Make sure that we're on target for anything new that we're adding into the product, and also making sure the things that we previously had in the product still work for everyone. Finally, for the scenario refinement, we're going to get feedback as people start to try this stuff out and they plug it into other efforts that they have going inside of their facilities. We're probably going to get a lot of feedback on, hey, if you did this for safety, that'd be really great. Or, hey, if you could help me count how many pieces I made in an hour, or if I have some kind of bottleneck in my system that I can address. So as we learn these scenarios, we'll consider them and reprioritize them and schedule them in one of our future sprints.
Yeah, that sounds great. Yeah, for example, we always want to make sure we're meeting our customers' needs and maintain a feedback loop that makes sure that we're meeting their requirements. And once we've kind of established that review process and the design, we kind of went into a development process where we used an agile developer process where we worked in really tight sprints of 3 weeks with using GitHub for collaboration. If you go to our repo, you can see all the commits listed. We partnered with Linko Networks. They're an ISV in Asia, and they worked with us to develop this application. What you'll see in the demo is actually all of their dev work, and we're very grateful to them for it. And of course, each of these sprints were kind of gated on a scenario demo that when we finished the sprint, we had to be able to show that we could achieve one of the ICANNs in our document. David, you kind of came up with the sprint process. Do you want to kind of talk more about how we brought Agile into this conversation?
Well, we assumed Agile from the beginning, since we need to get this thing quickly out. We just like feedback on a product, we need to get feedback on our team and how we're developing stuff. And so Agile is really the way that we needed to go for doing that. I will say one thing that's kind of interesting is since Linker Networks is over in Taiwan and we're in completely different time zones, we use that to our advantage. So at the end of our day, we can tell them what to work on for their day. And then when we get into work in the morning, we can see what they've done, try it out, and then give them feedback for the following day.
Yeah, that schedule difference has actually been really helpful because it allows us to maximize the time that we have for development. So now that we've talked about the design, the requirements, the review process, and the development process, we actually had to go build the thing. So let me show you what we came up with. I'll go ahead and show you a demo of our current stage manufacturing solution. So here is the current UI. It looks very similar to some of the mockups we created. And let me go ahead and register a new location. This would be like an area in a factory. For example, production line 1. I need to be able to type first.
This is basically what the camera is going to be pointed at, right, Anjay?
Yeah, exactly. So this is going to be pointed at a production line that makes cats. Not real ones, but 3D printed ones.
Toy cats.
Yeah. Save it. And then we need to add a camera. So this solution relies on RTSP cameras. That's a very standard video streaming protocol. So cat line 1. And I have a handy dandy RTSP URL. And submit that. Now we have a camera. So we can click on this camera and we can configure a job for this device, which means I have a camera. I need to add a part, of course, which means I need to train a part. So there's no parts in this library, which means that there's no models trained to provide analysis at the edge from the stream from that camera. So let's train a model and create a part first. So it's cat toys, plastic cats.
Notice that we don't have terms like train a model in the screen anywhere because we're trying to target somebody who doesn't have expertise with machine learning.
Right, exactly. I'm actually using words that we've kind of found to be too technical for the audience we're trying to hit here. So we made sure all the language made sense to the personas that we're going to use it. I already have a camera registered, cat line 1. So I'm going to hit play. And I'm going to capture some training images. I need at least 16 for custom vision to work properly. So that's that, and let's see how many images we have here. Let's go all the way to the beginning there. Say, we're going to label it. Of course, we don't, use the term labeling because that's a very confusing term. So we just say draw a rectangle around the part. Next. Next. Next.
Now, Anjay, I know people watching this are probably thinking, hey, this could have been better here or there. And we agree. We just haven't shown this to enough people to get all the feedback that we need.
Yeah, absolutely.
But we will. We'll continuously improve on our user experience as we learn more.
Yeah, absolutely. This is always like a continuously evolving process. We never at any point want to say, we're done. This is it. It's sealed and forever this way. That's, kind of what makes the cloud so great is that we can innovate at that kind of speed and we don't have to worry about boxing up the software. I'm going to keep labeling here because I think I took a lot more pictures than I was supposed to. Okay. Oh, wait, what happened here? I'm just going to save all these right now. There's 21 pictures, so just the last one. Okay. And he lives right here. Now this model is not going to be super accurate just because I have, taken 20 pictures. The more pictures you add, the better it goes. So we'll of course encourage our customers to take as many pictures as possible. But I'm going to save this, which means these images are now being transmitted to Custom Vision and being trained.
This is a big deal because manufacturers typically produce parts for which there is no existing model. Like every single kind of widget and doodad is manufactured, and there's no way we could have a picture or models for all of those things. So we really wanted to focus in on making an experience super easy for you to create your own new model based on the unique thing that you make as a manufacturer.
Right, exactly. So this is customvision.ai. It's a way for anyone who doesn't have data science experience to quickly train a machine learning model that identifies certain images by just uploading images and tagging them. And it also has an API that we're taking advantage of to train and get this model downloaded. So this is a model I've trained earlier, a project I've preceded earlier. You can see all the pictures here, the labels I've set for them, and I will literally click train, and I'll be able to download the model. It's very simple, very easy to use, but we're making it even easier and accessible to those who aren't in the industry.
Yeah, instead of sending people to multiple websites, we're bringing it all together here by calling the APIs and bringing the full solution end-to-end together for this user.
Exactly. So we're going to go ahead and finish configuring this job. So cat line 1, cat toy part, production line 1. And we'll go ahead and click configure. So we're still sending the data up to the cloud and waiting for the model to come back. So we can see that the model's done training. It's been uploaded to blob storage, and then we downloaded it and then passed that URL to the module twin that controls the inference module that we talked about earlier. The module twin is an IoT hub construct that allows you to dynamically change properties of a module while it's running and get information back out of the module. So we told it dynamically, go look for this model, apply it to this camera feed, and start inferencing. So let's see what we can see here. We're going to play, and you can see it's barking the cat toy. It's a little bit inaccurate because of how we trained it, how quickly we trained it, but you can see it kind of getting the gist of it and highlighting that particular cat toy as it comes across the production line. Once this is done, we may have images that are low confidence, and you might want to be able to improve the model. So then we can go to something that we like to call retraining. So let's select this part, and we can see images here and a confidence level. And we can see where it wondered if this was actually a cat toy, and it actually got it, if you can see there. So I'm going to click yes and identify. They got it right. And we're going to extend it to make sure it's got the full toy and save. And this is one, there's no cat toy selected here. We're going to click no. And this one's got a cat toy. And then identify. And this is not actually where the toy is. It's over here. And then save it. And we can continue doing this for all the pictures that it's collected. We're going to do these 3. I click update. This model will then be retrained and redeployed. And we'll hopefully have better inferences the next time around. So that's kind of our stage 1 work. You've got the ability use very non-data scientist and non-computer scientist friendly terms, the ability to set up a camera, get its feed, then take some images from that camera, use it to train a model, and then get that model and run it against the feed from a particular camera. And you can do this for a couple of cameras. And even further, we can take low confidence images, retrain them, and then provide an even better model. And again, this is all for someone who the day before didn't know what data science or how this worked. And
yeah, one of the things I really love about this, Sanjay, is it involves the person with the expertise about that part, which is the person working in the factory. And it allows them to share their knowledge with our machine learning system without them needing to be an expert in machine learning.
Right, exactly. So now that we've got these scenarios and these ICANNs down, what are the next ones? Like, what's in the future for us? David, can you talk about like what you'd like to see go forward, happen with this product going forward?
Well, first of all, we're of course always improving our Azure Stack Edge uh, form factors, as well as our Azure Stack Hub form factors, making form factors that are appropriate for different verticals. In manufacturing, often you don't have a data center to go and plop a rackable server into. So we'll be working on new form factors. The key scenarios we're really looking at is not just part identification, but within a part, are there defects that need to be identified? And then, as we mentioned earlier, how do I count how many parts are in a location so that I can do things like know how much was manufactured in a day, or know if there's a backlog within my manufacturing processes that I need to address. Finally, I think we really want to look at how we could run this completely disconnected from the internet and not rely on calling a web service like Custom Vision AI up on the internet to do the full end-to-end scenario, so that it could be completely autonomous.
Right, so that sounds like a great book of improvements for the future. So that's kind of what we've got today. Here's what you as a viewer can do next to get started with Custom Vision, Azure Stack Edge, or these patterns and solutions that we've made available. So we've got a few aka.ms links that show you some solution architectures, some tutorials, and the code for manufacturing solutions like these and other solutions we put on the internet. You can reach out to us if you're an ISV and you want to be able to publish your solution on Azure Stack family, either that's Azure Stack Edge or Azure Stack Hub. And in the future, we'll be having a hybrid virtual event where we'll talk about these kinds of scenarios a little bit more in depth. So that's all we have for today. Thank you to everyone for tuning in and watching, and have a great build.
Thanks everyone for your time.